What's going on, guys? Welcome back to this video. Today we're going to talk about Lumma Malware. Lumma is a type of information stealer that aims to steal your credit card information, passwords, session cookies, and of course the balance stored in your cryptocurrency wallets if you have any balance. Today we're going to perform a full malware analysis. Basically it is dynamic analysis using Any.Run. Alright, what are we waiting for? Let's get started. Let's look now at the evolution of the Lumma malware. So in 2022, Lumma malware was observed and detected and determined to be from Russian origins. In the same year, in 2022, the developers of Lumma malware started to market the malware. So what does that mean? It became a professional grade tool. So someone or anyone can actually subscribe and get the malware. So it became Malware-as-a-Service. Anyone can pay some money, and then get the malware so that they can use it for whatever the purpose. And in the same year, in 2022, it was observed that the developers and also the users of Lumma malware are targeting Windows 7 up to Windows 11. Now, when we call Lumma malware, or when we classify Lumma malware as an information stealer, we have to find out what are the information that Lumma malware steals. From the analysis, we can summarize these targets. So basically, first, Lumma malware aims to steal 2FA authentication details if they are stored on your computer or on your browser. Next, it aims to steal cryptocurrency wallets. So if you're a cryptocurrency enthusiast, or if you have wallets stored on your computer, you have to make sure, or you have to be careful of such threats. We have browser cookies and extensions. Now, when Lumma malware steals browser cookies and extensions, it actually exfiltrates or sends them over a secure channel to a C2 server controlled by the attacker or by the user who bought the Lumma malware. As we saw earlier, that Lumma malware can also be bought by users. So here, the impacts when browser cookies and extensions are stolen, what happens, the attacker can now log into the victim's accounts without the need to supply the passwords. For the credentials, we actually talked about this. Now here, the credentials are actually the plain text passwords. So if your browser stores plain text passwords, such as when you log into a website, the browser asks you to whether you want to remember the password. Now when you click on remember me, the browser stores the password. Now it happens, Lumma malware can actually detect stored passwords and steal them. And of course, 5, the credit card information. If your browser stores your credit card details when you're making purchases, and if your computer is infected with Lumma malware, unfortunately, Lumma malware steals credit card information from the browsers. So as you can see, Lumma malware mostly steals the information mainly from the browsers and the cryptocurrency wallets. That's why it's classified as an information stealer. Here we see how Lumma malware is sold. So basically, as you can see here, first we have a link to the channel where you can actually buy the malware, and the other link here to report the bugs, and 3 is the logs market. So basically, if you don't want to buy the malware, you can actually just buy the logs. The logs are the credentials collected and gathered by the malware developers while they are infecting the victim's machines. So if you don't want to buy the malware, you can just explore the logs and buy the logs. So here's as you can see, for example, this log was observed, and here we can see, for example, 159 US passwords and 71,256 cookies can be actually sold with $9. You can buy them for $9. Okay, now that we have talked about how Lumma malware works and the timeline of its development, let's now talk about how it is delivered and when it started to target users. So Lumma malware campaigns started to target users in 2024. As you can see, first it started to target transportation sectors. Later, in the same year, it targeted other sectors as well. And the main medium or the channel that is used for the targeting, it was phishing and Malvertising campaigns. Usually phishing is the main channel that's used by attackers. So it is expected, it's not a surprise that Lumma malware uses email communications to deliver the payloads. And of course, the campaign actually was extended to target other individuals as well in the late of 2024. Another way the Lumma malware is delivered to victims is through the captchas. So when you are browsing a specific website, you may encounter a click to verify or a captcha request. So when you, this is an example where the captcha asks you to, as you can see here, to follow specific instructions. Press and hold the Windows key. So basically this will spawn the run functionality in Windows. The next step in the verification window, press Ctrl V. So here it is asking you to copy and paste the verification code or whatever as it claims. And lastly, press enter on your keyboard to finish. So actually what you're doing here, in order to verify or to access whatever the feature you're trying to access in the site, you're going to copy the code and execute it on your Windows system. Now, when we take a look at what is the actual instruction being copied, you see here, this is another captcha, verify who are you, and when you click on I'm not a robot, you see the actual instruction is a PowerShell command. So that is what is being copied, and that is what you want to paste in your run window in order to verify yourself. So this PowerShell script, when decoded from base64, it translates into an instance on Amazon AWS. Basically, this is the instance or the server used by the attacker to collect the credentials or the information stolen by the Lumma malware. When we decode the PowerShell command from base64, we see the plaintext form here. So what is this? This command actually is a native binary command in Windows operating system. But what's the objective of this command? It is to retrieve and download HTML applications. So basically it's going to retrieve the file from this link, okay, and execute it on the target machine. So when the victim executes this command through the run functionality, the command is going to download the HTML application or the execution code and execute it on the machine. Now let's see what happens when this command is executed and the dropper is downloaded. We're going to do the analysis using Any.Run. Now before we start the analysis, remember that in order to upload samples, you can create an account by clicking on the sign in. And here, if you don't have an account, you can sign up with your business email. Click on sign up here and fill in information, including the business email. All right, let's proceed to the analysis. All right, so remember that when the PowerShell command was executed by the victim, a dropper was downloaded. Now, usually the droppers are found, this is an example of a dropper. In our example here, the dropper name is Bafuna. And you can see the location, the full location of this dropper by clicking on more info. You can see the location is in the temporary directory. That's usually where most droppers and payloads are written to. So basically, that's the full path. And here, there is a warning about this executable, that it is executable content was dropped or overwritten. So this executable Bafuna was retrieved by another executable, okay? Or in the previous example, it was retrieved using could be retrieved by a PowerShell command that can be executed by the user. So what does this executable do? We have to follow the chain of the execution. So here we have this process, and it has 1348 process ID, and we can see that there is an executable named program. This was spawned by Bafuna. If we take a look at this program, and here on the lower right, we can see that the executable tries to connect to an external IP address, checks for external IP. Have a look here. That's the process name, program. So it is checking on the destination IP that starts with 104, and the destination is 443. So it is doing this over the HTTPS protocol, right? Retrieving something from the web. Okay, and there is another executable here called ASP.NET_WP and categorized as malicious. If you have a look here, why, you can see that it is the actual Lumma, or it contains the actual Lumma payload. Despite the fact that this executable is part of the .NET framework, now it is hooked with the Lumma payload. Click on this, Lumma Mutex has been found. The operation is create. And we can see here the reasons according to the MITRE ATT&CK framework. These are the tactics and techniques, why this is categorized as malicious and why it is categorized as Lumma. We see here the first action is stealing of personal data. We click on this and we see this. So here the operation is create device disk file system. And this is the affected path. You see the affected path is the user profile on the Chrome browser. So it is retrieving and reading the cookies of the user. Next, we see another tactic, steals credentials from web browsers, and we click on this. We see also the path leads us to the Opera browser. And another one, this one is Opera as well, looking up. And here is the Yara rule. We can also have a detailed look at the artifacts or the locations on the system where the malware tries to make modifications or changes. We can click on the deep, and here we can see the changes classified according to the severity. So we have danger, we have warning, and we have other. If you want to focus on the changes categorized as danger or under the danger category, you can just click on the other categories to rule them out. So we click on this, and we rule the warning category out, and we are left with the dangers. So here we can explore the locations on the file system, as well as the registry keys being modified or being modified by the malware. You see, most of the locations where the malware tries to access or changes is the actually they are the user profiles on every browser. So you have the Microsoft Edge user data, and actually this is expected since the malware is classified as an information stealer. It's expected that the malware looks for these locations and tries to modify entries as well as exfiltrate. So here we want to see what are the C2 servers to which these information are exfiltrated. We can go back to the original view here, and here through this button on the IOC we can click, and here we have a brief of all the artifacts that matter to the SOC analyst and the forensic investigator. So we have the hash of the sample, as well as the DNS requests that are classified as malicious. Now, here are the URLs. As you can see, all these URLs, domains, the IP addresses, they are suspected to belong to the C2 servers where the actual data is being exfiltrated to. We can have an example here. We can copy this and you can click on the TI, the threat intelligence, where you'll be able to look up the domain. As you can see, when I look up the domain, I can see here that there are results indicate that this domain is malicious. I'm gonna refresh the view. We can see this is the verdict. The domain is malicious, and it is actually these are the IP addresses, and this is the categorization. It's connected to the Lumma stealer, and these are the analysis sessions that have been conducted on the samples. These samples they are found to connect to this domain, right? That's why the domain was found to be malicious. And these are also the IP addresses, as we have noted earlier. You can also look up other artifacts. Okay, now if we go back to other droppers that have been delivered by the malware, we see that we had ASP.NET, which was actually categorized as the Lumma malware. The other dropper was the program. Now, in Any.Run, you can have a look at these files separately by clicking on the files here at the lower left. And we have all the executable files dropped by the malware. Among them is the program.exe. You can have a look at this. And Any.Run, you can have a static analysis on the executable. Here we have the main view, we have the hashes. Basically, all the information that you want to get out of static analysis, you can just get it here by clicking on the file itself. And of course, you can see the hashes. You can also look up the hashes as well in the threat intelligence section. This is the hex view. And of course, don't forget, when viewing the hex representation of the file, it's very important to take a look at the signature. Now, this is, as you can see from this, we can conclude that this file is actually executable. Now, sometimes you encounter steganography cases where the file appears to be an image, but upon viewing the file using a hex viewer or while doing static analysis, we discover that the actual signature differs from the file extension. So it's very important to have a look at this signature here. And this is the portable executable header. Okay, what we can do here, we can just download the sample if you want to discover it on your own, or you can just submit the sample for further analysis. If you want to open a new analysis session, you can just submit to analyze. For now, we understand and we know what's the context of this executable. It just checks for the connectivity to the main C2 server. We see here that there was a warning, system network configuration discovery according to MITRE, and we saw that the program was trying to check for connectivity to the destination IP address belongs to the C2 server. And lastly, of course, you can click on the text report and we have a detailed report of everything we just analyzed. All right, now remember that if you are doing this as part of a incident response activity, you want to know the tactics, techniques, and procedures that the malware uses. So basically we can click on the ATT&CK and here we can see all the tactics and techniques. So we have two tactics here, credential access and discovery. These are the tactics used by the malware. And under every tactic, or the first tactic, credential access, we have two techniques: credentials from password stores and secured credentials. Basically, it's trying to steal the credentials. The discovery here, because the malware tries to retrieve information from the registry, we have a query registry, and also the system configuration discovery, where the malware tries to connect to an external server. So these are the techniques and tactics. These are important if you want, or if you're conducting this as part of an incident response, you want to build a profile about the attacker and their tactics and techniques for future detection of the same or similar activities. If you click on the summary, it's still in beta, but you click on the summary and an AI summary is generated. Now we click on the requests, we also see a summary. This URL is used for a post request to the host. We analyzed this host, if you remember, using the threat intelligence feature, and we discovered that it is malicious. With the URL path /API, the IP address is probed by program.exe. Remember this one? So we go back here. So this is the IP address and the port is 443. The request wasn't detected as being sent through a proxy and the response status was responded with an HTTP code of 200. The country origin is the US. And that's basically because this is the C2 server, and at the start of the infection, the malware probes the C2 server for connectivity. Legitimate programs may use this event to send a post. Okay, so that is the summary by the AI feature. And don't forget that you can export the analysis using different formats: JSON, HTML document, and also zip. All right, now we're going to move on to analyze a different sample. It is the same malware in Lumma, but under different, or it is delivered through different methods. All right, now let's look at another case. This innocent GitHub page hosts what seems to be a Solera executor, which is an ultimate Roblox script executor. It's a basic program, right? Now, what happens when you download the program, you will get infected with the Lumma malware. So GitHub, or the executables you find in GitHub, cannot be 100% safe. You have to be careful. All right, now when we upload the sample to Any.Run, let's first start with the process tree analysis. All right, so here we have the Chrome process, and it's normal that the Chrome process appears here because the payload was retrieved via Google Chrome, right? We downloaded Solera executor from Google Chrome. So we're gonna ignore the Chrome processes for now, and we're going to scroll down to the process that operates the main executable, Solera executor. And that's where the process comes. We have this process. Now, upon launching the process, you can see here Any.Run has indicated the presence of another executable, the name of which appears to me, it doesn't appear too much good, right? So it warrants further analysis. All right, so we're gonna ignore this for now and follow the process tree. The third process was the CMD, and it executed a PowerShell script. Now we confirm the suspicions, right? We see partial execution, and also we see a suspicious process launched by the main Solera process. So how do we start the analysis? Now basically that's where Any.Run comes in. Instead of dynamically analyze the process, launching several tools at the same time, we can just click on the executable that we actually suspect, and we can have a look at the verdict down here. So we're going to start with the actions that are categorized as warnings. As you can see, these ones in yellow are categorized as warnings. It's better to start your analysis with these warnings. So we have the first warning, a tactic used by attackers usually starts a CMD for command execution. We can click on this and we can see that the command is the partial command we saw earlier, this one. So let's start with analysis here. I'm gonna copy this and go to Cyber Chef. Now, the hard part of this command is the part encoded in base64. So what we can do here, we can remove the plaintext parts and keep the base64 encoded. Drag from base64 here and remove null bytes. You have the complete recipe to decode the base64. So we have this output. Okay, so in the output here we have add MP preference. Add MP preference is a PowerShell cmdlet that's used to change the preferences of Windows Defender. So there you go. We have an executable that is trying to evade the protections. Dash exclusion path. So basically, what are the preferences that the executable trying to change? It's actually manipulating the exclusion path. What are the paths that are intended to be excluded? We have the user profile and we have the system drive. So everything, all the executables dropped under user profile. Usually it's C users, the name of the user, and system drive, usually it is the C drive. All executables, all files will be excluded from the analysis, technically rendering Windows Defender unusable in this case. So we can safely conclude here, go back to here, yeah. So we can safely conclude that this PowerShell command disables Windows Defender, yet in a soft way, right? Instead of completely disabling the antivirus, it just adds exclusion path. Nice. All right, let's move on to the next action. Creates file in the system's drive root. So this looks to me that there's a file named logs UCE being created in the C drive. Usually this file may hold the activities of the malware. I don't think so, or maybe we have to check later. Let's leave this for now. It's not important. All right. Next, we have potential corporate privacy violation. So here, this executable that we saw earlier, probably this executable was retrieved from the internet. We're gonna have to find out how the Solara, the main executable, downloaded this suspiciously looking executable. We're gonna have to follow on the execution chain. Process requests binary or script from the internet. Let's have a look. Here you can see this process, okay, is retrieving another executable from this IP address. And the executable name is XMRig. Now, looking up XMRig on Google reveals that this is a crypto miner. So you have a classic case of crypto mining activity. Crypto mining is a type of activity where you actually mine for the cryptocurrencies. So what happens here is the Solara executor, or the developer of this executable, wants to use computers or to deploy botnets and use them to mine for cryptocurrencies, basically harnessing the processing power of the victim's computer to mine for cryptocurrency. So this is a classic case of crypto miner. Now we can move on and see connects to the server without a host name, right? That's the IP address, that's the C2 server, and that is the main crypto miner. Cryptocurrency mining activity detected. We can have a look here. So this is the destination IP, and this is the destination port. Basically, these are the connection parameters of the C2 server. Drops a system driver. The system driver that was dropped here is this WinRing64 sys. And Any.Run comments on this is that it is trying to possibly evade defenses. Okay, we already have determined this from the PowerShell command. Executable content was dropped or overwritten. Okay, it was changed probably. Yeah, this one, win logon. And look at the path, C program data, DLL host, win logon. These two files, this one and the other one, warrants further investigation. But for now, we know the purpose of the malware. All right, so let's go back here. So the assumption now is that this executable is a crypto miner, right? Now, if you click on the main one, Solara, we can see Any.Run telling us that this is Lumma Malware. Safely be said that this malware is a dual purpose malware. It is information stealer and crypto miner. Now we can have a look here at the reasons why this is classified as Lumma. We can see it is trying to mine for the personal data of the users starting from the web browsers. And we can see that connects to the server without hosting. There is a network activity. We can click and see that it is actually retrieving. Probably this is the command that was used to retrieve the crypto miner. So here it connected to the IP address, happens to be the C2 server of the attackers, and it retrieved the crypto miner. So Solara is the information stealer, and this executable is the crypto miner. Now, these PowerShell commands were actually executed first to softly disable the Windows Defender, and we can see scheduled task. Let's have a look here. Now this scheduled task, click on more info. That's the scheduled task. So we start first with /c. cmd/c meaning it is actually executing the following command in a new session. Scheduled tasks /create /scminute mo5. This is to create a scheduled task that executes every 5 minutes. /tn DLL host. That's the name of the scheduled task, and that is the executable DLL host. So DLL host is actually running every 5 minutes, probably to check the connectivity with the C2 server. This is just an assumption. You're gonna have to find out. Let's go back and see here what are the other commands. Here another scheduled task that is running every hour and also runs DLL host. Okay, let's go back, and that was it. Now we can go to the files section here, and maybe we want to search for the files that we couldn't analyze earlier. So basically, if we go back and click on the main executable here, we see multiple warnings. We want to have a look at, all right, let's look at this one, the CryptoMiner. So we want to see here, creates a file in the systems drive. There were 2 files dropped in the program's data directory. We will have a look at these files. So this one is the main CryptoMiner, drops a system driver. This file is interesting. Now, when you want to analyze a file, basically you can just use the files section here and look for the file. So you can type .sys to extract or look at the file. Yeah, this is the file. Click on main. This is an executable file, and here we can see the hashes. All right, now what we can do here, we have 2 options to analyze this file. We can submit to analyze, and this will open a new analysis session using Any.Run, or we can use lookup on VirusTotal. So here we can see we have 3 hits. So it is a vulnerable driver. Click on details. These are the comments written by the community. Going back to details, you see other names of this file. And these are static analysis information. I'm going to click on relations. Okay, execution parents. Usually this driver was executed by these executables, and they all look suspicious or malicious. Resource parents. So indeed, if we now go back to Any.Run and look at the comments left here, see possibly attempt to evade defenses, and that was true. It's a vulnerable driver to aid in the defense evasion. All right, now we have analyzed the processes, we have analyzed the files. Now it's time to conclude this analysis by clicking on the IOCs section, which will summarize the indicators of compromise. This is the main URL. That's your first indicator of compromise. That's the main infection point. This is where the malware came from. So that's the URL. These are the files dropped. And also we can see other artifacts that were queried by the Lumma malware. For example, here we have the Google Chrome, the user data or the user profile path. And this is actually logical because the Lumma malware aims to steal the web browser information or web browser credentials. We have the main domain. This domain is resolved to this IP address. And we saw earlier that this was the IP address from which the main CryptoMiner executable was downloaded. Now what we can do here, we can look up the IP address or the domain name using Any.Run's threat intelligence feature. Let's see here, have a look at maybe the domain. Okay, the verdict is that the domain is malicious. So it is malicious. And here are other IP addresses. And here we have the analysis sessions where the domain was detected. You see all the analysis sessions classify the activity as Lumma stealer. See? You can also analyze the IP address, but that's fine because that's enough because the IP address resolves to the domain name. And here we have other IP addresses. And these are the URLs. So basically what you can add to your report is the IP address, okay, domain name, And do not forget the hashes. Lastly, if you want to have this as a text report, you can click on text report, or you can export it and choose from the listed formats. Now you may want to practice on your own. So what we can do, you can visit Malware Bazaar and download the sample. Here you can click on download, but do not execute the file in your main OS. Download the sample, go to Any.Run, click on new analysis, and you will be able to launch a new analysis session. So I did that, and here I saw kind of different results to what we saw earlier when we analyzed the Lumma malware in the previous two cases, the GitHub one and the Captcha one. So here, when I launched the executable, there was a command executed from the command line, and it looks weird. Let's go ahead and analyze it. So here we have, click on more info, C Windows cmd/c/c launches the command or the following command in a new shell session. Expand, it decompresses. What it does, it decompresses the contents of Indonesia text file and writes the contents into a new file named indonesia.txt.bat. So it is a batch file. And then it executes the bat file. All right, so we have to analyze the bat file here. Let's have a look at the warnings displayed by Any.Run. First, the first warning, get information on the list of running processes. Task list. Okay. Use find string to search for text patterns in files and output. So that's the text pattern. It doesn't look obvious. Okay. Application launched itself. Starts CMD for command execution. We have a command cmd/c md5865. This is all obfuscated. Starts the auto LT3 executable. Okay. This jonathan.com is looks to me as an executable stored in temp, and that's the command that is executed, and we have then starts application with unusual extension. Indeed, jonathan.com is an unusual extension for an executable file. The verdict here is that this file is malicious. So what we're going to do next, we're going to have to do actually the analysis on the bat file. Let's go back, and maybe you can retrieve the bat file by clicking on files and then use .bat. That's the bat file. And these are the contents. You see we have gibberish, meaningful names. So this is some type of obfuscation. To deobfuscate the batch file, just download the file, okay? And then you can use batch deobfuscator. Here, let's go to my virtual machine. The tool name is batch_deobfuscator, can be found in GitHub basically. You can download the tool from this link. Once there, I'm going to execute Python batch interpreter -- file, specify the file. Remember that this is the file that we have downloaded from Any.Run. We just want to deobfuscate the contents of this file. So this is the deobfuscated version. We're gonna have to copy this. Whatever we can do, we can just send the output to a file named hack2.bat. Okay. Now we're gonna double click on this and have a look at the file. We're not going to execute, we're just going to open this in an appropriate text editor. Okay, set. These commands are used to set environment variables. But the values here, they do not look meaningful. So this is meant to thwart the analysis and divert the efforts of the person who's doing the analysis. So we're going to ignore all of this, and we're going to stop here. Find string. So here it looks, or it searches for a pattern of string, as you can see. Actually, Any.Run has stated that earlier. We saw that here. And we're going to go back to the command, click on more info. And remember that Any.Run has told us it uses find string to search for text patterns. We can verify this here from this command. Next we have if not error level ping -n. So it's making a connection to this IP address. It just uses ping. Then we have another variable set. Ignore this. Task list, retrieving the list of the current processes, which was also highlighted by Any.Run here. Get information on the list of running processes. So in the background, Any.Run does some deobfuscation for you. And then we have find string command, and we have these PD service host, avast UI, avg UI, Sophos health. So what happens here is that the batch file looks for the presence of an antivirus solution by looking for the signatures. These are known signatures for antiviruses. If they are found on the system, it means that there's an antivirus installed. So here it looks for, probably here it's trying to do some evasion based on the output of this command. And we have this command executed. We still don't know what the command does. Scrolling down. Yeah, look at this one. Set/p mz jonathan.com. So it's appending the mz, the signature of the any executable file in Windows, into jonathan.com. It's trying to make this file an executable file because, yeah, the extension is not an extension for an executable file. So if you try to execute this on your own, it's not going to work. Windows will complain that this is not a valid file. So the malware here appends the mz signature so that Windows can execute this. So this is the file of interest here, Jonathan. This is the payload. Scrolling down, we can see find string consent. Jonathan, okay, this is not important. Look at this one, cmd/c copy. So it performs a copy operation to copy the contents of legs, effects, attorneys, viewer, tails, defense, 5, cardinals, Bosnia, penalties, concatenate the contents of all these files using the plus sign, add it to Jonathan, and store the output in a new file named, let's see here, the new file name is the same. So it's adding the contents of all of these files to the main file, Jonathan. So it is building the payload. Scrolling down, we can see another copy operation to copy the contents of these files and store it under this file, q.a3x. All right. And at the end, it runs the executable file and uses this file, qa3x, as an argument. That's how the payload runs. So if we go back now we understand how it works. So the main file we want to analyze next is Jonathan. This is the full payload that was dropped or retrieved by executing the batch file. So .com, search for the file. Here we can see Jonathan. You can click on this file and you can use submit or lookup on virus total. If you want to analyze this file, here you see that Jonathan was flagged by 41 antiviruses as a Trojan. Click on details, other names for this file, imports, relations. All right. Okay, look at this one. We have these two files, incidents and Indonesia. These two files we saw earlier when we were analyzing the file, the main binary. And we have the Jonathan, the file we're analyzing. It's also categorized as malicious, 17 AVs. Click on community, we can see what the people are saying about this. So it is a malware, Lumma Malware. All right, IOCs for the report. Don't forget to write your report and list the IOCs. And before we wrap up, I wanted to let you know that Any.Run now supports real-time Android malware analysis. You can now upload any APK file to Any.Run Cloud Sandbox and have it analyzed in seconds to find out whether it is malicious or not.